Hi students, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. And in this session, we are going to solve the mystery of organic chemistry. So what I have seen whenever I ask students who are preparing for JEE Mains or JEE Advanced, the first question that is asked is, okay, which is the branch that you hate the most in chemistry? And the answer is like, especially for JEE aspirants, the answer is organic chemistry. Now, ma'am, why organic chemistry? Because we don't study organic chemistry in a sequence that is required for us to study. So, this is actually a basic video of organic chemistry, right? That first we will talk about the origin of organic chemistry, why it is so important, what we are going to study in this full 11th and 12th class for your JEE Mains, JEE Advanced, what kind of questions that you should prepare yourself like for in next 2 years, right? If you are in class 12, then in next 1 year, right? Okay, understood everybody? Now let me know in the chat section that how many of you are like 10th moving 11 students, right? Let me see in the chat box, because this session is very interesting for all the 10th moving 11 students, right? Because if you remember that you have done carbon and its compounds, just imagine you stretch carbon and its compounds to 2-3 books, right? That is full organic chemistry that you are going to study. And trust me, if you genuinely study organic chemistry, the way it should be studied in a sequence, then I can guarantee that you are going to fall in love with this, right? Because it all organic chemistry wants from you is like to understand it, to actually understand the mechanisms, not to cram anything, right? To understand anything, you should know that what exactly it is, right? Okay. Yes, grade 9. Okay, Abhijit. So, grade 9, grade 10 or 10th moving 11 students are like totally on the right point, because once you move a little bit ahead of this, right? Once you prepare your mind for this will really help you to score good in your JEE Mains, JEE Advanced. I believe that those students who are in class 9th or 10th and 10th moving 11th as well, if you're right now watching this lecture, then trust me, you're on the right track, because I have seen myself very rare students who are that much aware when they are in 10th class, when in 9th class, or they have just started their class 11 journey. Most of the students are chilling, relaxing, but those students who are aware that, okay, this is the thing that I want to achieve, and organic chemistry is going to play a very, very crucial role in that, students. Because if you talk about physics and chemistry and mathematics, we know that physics is time consuming. We know that mathematics is time consuming, right? But in chemistry, physical chemistry can be time consuming because of solving the numericals. But inorganic is way too direct, but you have a lot of cramming in that. But still, it is very, very, very important, and that is also very interesting. That totally depends on the teacher. But organic chemistry is something where you don't have to as such cram things. You have to practice a lot of things. But if you practice good, trust me, it is not at all time consuming when you solve the questions in the exam, right? Okay, so students, let us start. Let us start it without wasting any time. First thing is, why I'm saying all these things to you. Firstly, let me just introduce myself to you. Students, this is your ma'am Diksha Kaushal, and I have done BSc MSc in chemistry, right? And I have been teaching the NEET and JEE aspirants from last 8 years, right? And I know from the mistakes that students have done that what are the things that other students should not do, right? So in this journey of your JEE advance, right? Because your aim should be very high, right? You definitely need a good team like you have in Vedantu JEE English, right? And guys, one very important thing that, you can see our shining stars here of Vedantu. Can you visualize yourself in this position, at this position? Right, just see, AIR 15 Karnataka state rank 1. Do you want to be like them? If you want to be like them, they are the students who have done like a lot of hard work. A lot of hard work means they have done the hard work for like 2-3 years dedicatedly. They have practiced a lot of hard work they have done, right? With the right mentorship, with the right guidance, they have done all this, right? So I want you guys to I want you also to be here, Then students, for our offline enrollment, right now we are providing this, it's the start of the year. So we are providing you IV SAT scholarship program. The registration is completely free of cost, right? This is 90% scholarship. That means depending upon your aptitude, your marks, you can avail up to 90% scholarship in the offline courses, right? And we are all the repeaters or droppers. If any dropper or repeater is watching this, then we are also providing rank guaranteed improvement, that your rank will be improved. Otherwise, 100% fees refund will be there. You can see for yourself that the amount of confidence that we have on our students and our teacher, on the content that we teach, right? Vedantu itself is famous for the content, right? Not for anything else, but the content, right, that we teach. And an educational institute should only be famous for the content. And I'm so proud to say this, right, that we are famous for the content, for the students, that they tell us that, ma'am, the kind of content that you guys provide, even on YouTube, even in the offline center, is just awesome, right? Now, you can, if you're from Bangalore, then students, you can visit JP Nagar Institute, JP Nagar Center, right? That is Vedantu Institute only, JP Nagar Center. And this is our number and this is the address, right? And for all the students who are not living in Bangalore, but they need guidance, this is for every student who are in class 9th class, 10th class, 11th, you have just moved out of class 10th, class 12 students, or even the droppers, right? The counseling that you need, we are providing it in our offline centers. You can go and check that out, right? Okay. So let us start now with the organic chemistry. Yes, students. Now, okay, tell me one thing. What do you mean by organic, right? What do you mean by organic? Organic means natural. Ma'am, organic means natural. So whenever we talk about organic compounds, by the name, it should be like they are natural compounds, right? That should come in your head. But it was also the same thing that was assumed by the scientists long back, right? They assumed that, okay, these organic compounds are natural compounds, like we have urea, right? All the compounds that are near us, don't worry, I'll tell you about the organic compounds also near us, right? Now, let's talk about urea, right? Out of urine, when you pass the urine, there is a compound called urea that is extracted out of your body. Now, that is an organic compound, right? That was under the category of the organic compounds, that these kind of compounds that are naturally from the universe, or only we have, they are called the organic compounds, right? The scientists assume that there is some vital force, there is some godly force here that is giving us these kind of compounds. We can't prepare ourselves these compounds in the laboratory, right? So vitalism, that is the theory of organic compounds, an old belief that organic compounds could only be made by living organisms possessing a vital force, that we have some natural vital force, right? And because of that, we are able to form those organic compounds that cannot be synthesized in the lab. That's why the name was given as organic compounds, right? Now, after that, what happened? One scientist called Wohler, right? Inorganic compounds, if you understand, inorganic compounds are obtained from non-living sources that do not contain carbon, right? These are called inorganic compounds. Inorganic compounds we study in inorganic chemistry. Organic compounds we study in organic chemistry, right? Now, Wohler created a method in which he converted inorganic compounds to organic compounds, right? Now the organic compounds were synthesized in the lab, and this gives rise to the birth of organic chemistry. That organic compounds are not only the compounds that can be just naturally produced by the living organisms, right? We can also synthesize them in the labs, right? That was the theory, right? But how Wohler came to this conclusion, right? So Wohler, what he did in 1828, right? Wohler debunked the vitalism theory. That means he was like, okay, this theory is false. This theory is not true. Why? Because he synthesized the urea. That is only synthesized by that is only passed out by the living organism. But he was able to synthesize the urea by slowly evaporating water solution of ammonium cyanate, right, NH3CN, right, which he had prepared by adding silver nitrate to ammonium chloride. Firstly, he added silver AgCl to ammonium chloride NH4Cl. Then he formed ammonium citrate NH4Cl. Right. After that, what he did, he slowly synthesized the urea. Urea is NH2CONH2. You see, urea is NH2CONH2. Okay, that is your urea. So urea he synthesized in this way, right? That was a very, very big deal at that point, that organic compounds are not like organic only. They can be synthesized in the lab. Now, this gave scientists a new thing, right, to experiment on. That if we can synthesize urea in the lab, we can also synthesize some new compounds in the lab. But now the question will be, ma'am, how can we synthesize it? Ma'am, urea was already existing compound, right? By seeing the structure. So how scientists see the structure, okay? There are some NMR spectroscopics, big name these are, right? So by these things and so many types of experiments, the scientists actually verify the structure that it has, right? So the same structure that was given by our body, is same structure is given by this lab, right? Synthesized product, right? So that means urea is confirmed that it can be made from in the lab. Now the question is, why scientists were so confident that they will be able to make other compounds also in the lab, right? For that, we firstly have to understand this thing, that what exactly is carbon. Because full organic chemistry is actually the study of carbon compounds, right? Carbon. Now, what is so special in carbon that based on carbon, we have a different chemistry only, with different branch only we have given it. That the compounds formed up of carbon, they are called organic compounds, right? So why, what is so special about carbon, right? So carbon is the hero atom, right? Why it is the hero atom? That is the second thing that is our question, right? So what we saw, like, let me just introduce this thing to you, right? Now, see, carbon has atomic number 6. Okay. Carbon has atomic, now I'm getting little bit into chemistry. Okay. Little bit touch of chemistry, what is there, right? I'm not going to get very deep into that. Reason being, because I don't want to puzzle you with that, right? When the time is right, we will understand about that. But now just understand, carbon is having atomic number 6, right? Okay. Atomic number, like every element has a unique atomic number. Like hydrogen has 1, carbon has 6, oxygen has 8, right? Every element has a unique atomic number. Similarly, if you have seen periodic table, right? Periodic table also, if you want me to make up a video of 10 minutes hardly on that, I'll surely make a video on, definitely one video on simple periodic table, how to learn that, right? Now this periodic table, if you see, carbon lies at 6th position. That means it is the atomic number 6. Atomic number 6, there is a thing called electronic configuration, right? Actually, the structure of atom is like this. This is the inside of atom, right? That we will study in class 11. In this nucleus, you have proton and neutron. Outside, electrons are revolving around it, right? So let's talk about electrons, right? So it's like in our house, we have like 2 people in one room, 3 people in one room, like that is decided, right? So same way, in this path, how many electrons will be there, right? So in this way, if we see this, what we have is the electronic, I think you have studied this in class 11, class 10, this is KLMN. This is how you studied your electronic configuration. When I will teach you structure of atom in class 11, I'm going to start with class 11 syllabus, right? In next week only, I'm going to start with that. Firstly, I'll talk about some basic moles of some basic concepts. Then basic, that is the name of the chapter. Actually, the concepts are not that basic in that, right? Then we will talk about structure of atom. And in structure of atom, that is the second chapter of class 11th. In that, you will learn about that how first you used to see in class 9th, you used to write it in KLMN. Now in class 11th, you will write this in 1s, 2s, 2p. Now, ma'am, what is this 1s? What is this 2s? What is this 2p? All of these things we will study in structure of atom. That's why I always say, before studying organic chemistry, one is electronic configuration concept should be code, like that concept should be completely clear to you, that you will study in chapter 2. And before studied organic chemistry, one more concept of chemical bonding, that is the chapter in inorganic chemistry, that should be clear in your head. Once these two and periodic classification, these three chapters are clear, then go to GOC, then I promise you that organic chemistry will totally fall in love. The problem is that students don't correlate the chemistries, right? They don't understand that how inorganic chemistry, this structure of atom is a chapter of physical chemistry, but electronic configuration is taught in structure of atom, which is used in inorganic chemistry, which is used in organic chemistry as well. So full inorganic, physical, organic chemistry are interrelated to each other. You have to understand this. If you don't understand this now, then definitely you will lose marks in chemistry because you won't be able to understand that. But once you have this thought in your mind that yes, they are correlated and I have to relate this in my mind when I'm studying one topic, trust me, you will be able to fall in love with chemistry because that's how chemistry works. That is interrelated, right? So now this we will study from structure of atom, right? Now, if you talk about atomic number 6, the electronic configuration is 1s2, 2s2, 2p2. This is the electronic configuration, right? If you see this here, in class 9th, you used to write 2 and here you used to write 4, isn't it? But just the expansion of this is, this K we are expanding to 1s, right? This L we are expanding to 2s2, 2p2, right? That I'll talk about in structure of atom, why we are doing this, right? Why we are doing this? Because in structure of atom in 9th class, you have only studied Rutherford model. You have only studied this Thomson model. Beyond that, structure is very different, very beautiful, very imaginative, right? Okay. So you are really going to see some really interesting things, and this part is actually, you might feel that this is difficult. This is the most interesting part of chemistry, right? So this electronic configuration I'll teach you in structure of atom. This is 1s2, 2s2, 2p2. Now students, this is called the outermost. This is called the outermost orbital. Can you see outermost? Now, inner core electrons are busy. Inner core electrons are like, no, I can't see anyone. They are like logged, right? Because if you see the structure of atom, right? If you see the structure of atom, this is proton and neutrons, right? And the electrons are revolving around it. This is what you have been taught in class 9. We will go beyond this. But at this point, you know this thing that electrons are revolving around it. See, if you talk about 1s, the electron is here near the nucleus. 2s, the electron is here. In 2p, let's say electrons are somewhat here, right? So that's how electrons are. Now, if you see this, the outermost orbital, the outermost, not orbital, the outermost electrons are very far away from the nucleus. So that's why whenever we are talking about any chemical reactions, we are studying the organic chemistry, we are talking about the outermost electrons that are involved here, right? Okay, okay students, I'll interact with you. Just let me just complete this concept, okay? So outermost electrons are involved here. Now tell me how many. This is outermost, this is called the inner core. This is called the inner core. And we are not talking, we are not concerned about any other atom at this point. In organic chemistry, you're only concerned about carbon. So don't ask me, what about nitrogen, oxygen? That is a part of inorganic chemistry. We will study that. Don't worry, right? At this point, we are only concerned about carbon. This is the inner core, this is the outermost. Now, outermost electrons take part in bonding, in reactions, right? So, outermost, you have 4 electrons. So, that's why it is called as tetravalent. That means it is able to make 4 bonds. Tetra means 4. So, it can form 4 bonds, right? Now, ma'am, how it can form 4 bonds? Now, that must be the question in your head, right? Okay, see this. See this. This is the carbon. Whenever we talk about carbon, only 4 electrons. It's not like carbon has 4 electrons. Carbon has 6 electrons. But we are talking about only the outermost electrons that are useful, right? It's like in your house, you have grandparents, right? You have parents, right? And you, right? And you have maybe some small children, right? Siblings, right? But whenever we talk about that who is earning, right? You only talk about the elders of the house, right? The kids, the 2-3-year-old kids are not earning, right? So kids are the inner core electrons that are protected, and outermost electrons are the parents, grandparents, right? The old people that you have, right? So now carbon, whenever carbon, we only talk about 4 electrons, and electron I am representing by this dot. Okay, 1, 2, 3, and this is the 4th one, right? Now, this carbon is like, hey, I have only 1 electron. I have 1 electron, 1 electron, 1 electron. 4 electron it has, right? Now, carbon is like, I need to make bond, right? I have 4 electrons. Now, what it will do, it will make a bond with some electron here given by some, like donated or shared by someone, right? Now it will take 1 electron here, 1 electron here, 1 electron here. Then can you see it will be able to form 4 bonds, right? It will be able to form 4 bonds. Now how these, you will think, ma'am, how can you say it has 4 electron and it is forming 4 bonds? That's why I told you that one thing is electronic configuration from structure of atom. That is the base of organic chemistry. Other thing, this whole thing, why it is so, how it can take electron, right? And here if I tell you, carbon shares the electron, right? Tell me why. Because of, in chemical bonding, you will study about this. There is a chapter called chemical bonding. In 11th class, that's why the students who lose marks and who are like very non-serious in class 11th, I can tell you in class 12th is hell for them, because nothing they will be able to understand, no? So class 11th, you have chemical bonding, right? In chemical bonding only you will get to understand that how bonding works, right? But I am not getting involved in it because it's a lecture of 3-4 hours to make you understand chemical bonding, right? So we will go line by line for that, step by step. Right now, just understand one thing, that it is 1s2, 2s2, 2p2. How many total electrons? 1, 2, 3, 4, 5, 6. And in chemical bonding, you will learn a rule that is called octet rule. What is the name of rule? That is called octet rule. That octet rule, oct means 8. That octet rule is saying, buddy, you need to have 8 electrons in the outermost shell. Right now, in the outermost shell, it has 4 electrons. So what do you think? It needs to have 4 more electrons. It wants to have 4 more electrons, right? So that's why we need 4 more electrons here. That is the reason carbon is making the bonds. Carbon is like, I want to make bonds because I need 4 electrons. And do you know how carbon is going to get 4 bonds? Carbon is going to get 4 bonds. It is very famous for the covalent bond, right? It is very famous for the covalent bond. Here I am writing octet rule, and carbon is very famous for the covalent bond. Now in the last lecture where I taught you some basics, only foundations, there I told you about covalent bond, right? Covalent bond is like, I have bought pizza, you have burger. Now give me a bite of burger, take one slice of pizza. It's like we are sharing. I am not giving my pizza, full pizza to you. I am not taking full burger from you. I'm like, let's share. Okay. So similarly, what will happen? And the most famous bond of carbon is with hydrogen, right? That is why the first chapter that you will study in class 11 is going to be GOC, right? That is General Organic Chemistry, which is like full base. And after that, the first kind of compounds that you will study is hydrocarbon. That means carbon and hydrogen, when they mix, what kind of bonds, what kind of compounds they form, right? Now, why hydrocarbon is so famous? Why? Because hydrogen kind of bond, it is very easy to make here, okay? It always makes like covalent bonds. And what kind of covalent bond? Let's say you had one electron here. Now tell me about hydrogen. Hydrogen is having how many electrons? Hydrogen is having how many electrons? This too you have studied in earlier classes also. Hydrogen is the first member, first member of your periodic table. That is, hydrogen atomic number is 1. It has just one electron, right? So because of this one electron, what happens? This is hydrogen. It is having one electron. This hydrogen having one electron. This hydrogen having one electron. This hydrogen having one electron, right? Now what it will do? What it will do? This carbon is like, yeah, I need one electron here. Hydrogen will be like, I also need one electron. We'll be like, okay, let's share. We'll share and this will form a covalent single bond. One bond is there, one bond is there, one line is there, single bond. They will also share, they will also share, they will also share. Now students, tell me one thing. This hydrogen has 2 electrons, this hydrogen has 2 electrons, this hydrogen has 2 electrons. This hydrogen has 2 electrons. And you will study this in your class 11th, right? And this you have studied also in class 9th also you have studied about octet rule. That I am teaching you only things that you have already studied, right? So that from that you can get a perspective of what is going to happen, right? I am not getting into too much complicated things, right? So now here you know that carbon is 1, 2, 3, 4, 5, 6, 7. 8. That means the outermost electrons are 8. In octet rule, hydrogen should have duplet. Duplet means 2, right? Hydrogen should complete its duplet. Other atoms should complete their octet in the outermost shell, right? That is why you will see this kind of structure, that is CH4, this kind of covalent bond, right? Whenever they form, sharing of electron is done, sharing of electron, then it is done with the help of covalent bond. Covalent bond, right? There you have covalent bond. Understood everybody? Now, let me see in the comment section what you guys are asking. Structure of atom that we will study. Yes. Okay. Okay, Vasuki, Abhijit, Naidu, Om, Sandeep, Yashi. Very good, very good. So, now let us see this thing. The next thing, students, that we have is, till now, if you have any confusion, then let me know in the chat box, because I am going to move little more deeper into it. Organic chemistry, what is that and all, right? Right now, I have just taught you what is this thing. That is, you can see here, why carbon is the king. Because of its tetravalency, it is able to make 4 bonds, right? And that also I have taught you why it is able to make 4 bonds, right? Okay, that's why it has this kind of structure that I have already taught you in the previous slide. Now, next thing is its property of catenation. Now we will study the property of catenation, right? I love to teach students with the help of my notes as well, because I know when I draw, they love it, that ma'am, that is like better for us to understand. So I know where you need my notes, right? So students, let's say this is one carbon, right? This is having, it wants to make 4 bonds, right? Now let's see, here also it has, I'll start with the center only. This is carbon, it wants to make 4 bonds, right? Now, catenation is a property of self-linking, right? That means carbon is like I want to be connected to carbon only. If there is one carbon, I want to be connected to carbon. It is not like it is not a very like a very common property that we see in compounds, right? But when you will study periodic table, right, this belongs to group number 14, right? Group number 14 elements shows this property of catenation, and carbon shows maximum amount of catenation, that is self-linking property, right? So what you will see, carbon will be like, oh, I have one carbon, I'll connect to carbon, right? Then this also have 4 bonds. This is like, here also I will like to connect to carbon. Here also I would like to connect to carbon. Here also I would like to connect to carbon. Here also I would like to connect to carbon, right? Then also again carbon, again carbon, again carbon, again carbon. There is no stoppage here, right? I can also link more carbons here, more carbons here, more carbons here, right? It's like I have to stop it by adding hydrogen here. If I put hydrogen here, then carbon cannot be connected further. If I put hydrogen here, 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 then carbon cannot be connected further. So I'll just attach hydrogen to all of them so that I can stop the structure here only, right? Otherwise, the catenation property, self-linking property, too many carbons will be there, right? Can you see, right? So many hydrogens I have to draw here, right? So that is the property of catenation. Here, so I have stopped at how many carbons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But what you will see, carbon is not stopping here. Carbon, because of this property, has 2 categories, okay? It is having 2 categories. Those 2 categories are, one is, because of this catenation property, 2 categories are there. One is very large compounds. Carbon also, like organic compounds, you will see up to 30, up to 100, up to 1000, right? Up to n number. That's why you will study in JEE Advanced, not in JEE Mains. In JEE Mains, it is not there. There is a chapter called polymers, very easy chapter, right? So poly means many carbons. When you have many carbons connected to each other, n number of carbons, right? Then you have polymers, right? Can you give me any example of polymers around you? How many of you have decorative PVCs around you? Polyvinyl chloride, basically these are, right? Okay. So if you see polyvinyl chlorides, PVCs in your houses that are there. Okay, chalo, PVC is a big thing. Let's talk about polythene, right? Have you used polythene? Let me see if I have any polythene here. No, I don't have that, right? Polythene, plastic. Okay, have you ever used eraser in your classes? Like when you were a kid, right? Even now when you draw pencil diagrams, right? You use eraser, right? Like this, I have this kind of eraser. Do you use eraser? Right? In reality, not in virtual digital world, in reality, you have the eraser, right? So that eraser, all these are polymers, right? Why these polymers are there? Because carbon can form very large amount of compounds, very large compounds, and even if it is making small compounds, why have to dedicate a full branch to carbon? Because not only large compound, it is also forming too many compounds, large number of compounds. It is not only forming large and big compounds, it is also forming large number of compounds, right? Okay, understood everybody? Because of the property of self-linking, because of the property of catenation, it is able to do so, right? Okay, okay. Arey Meenu, what's the problem, huh? Chill. Okay, relax a little bit, right? I think you need to take a chill pill, right? Because doing all these spamming things now will not work. That's not how you get into IITs and all that, right? You come here, like if you have anything to say it on my face, right? No, 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 yes, 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 yes. Okay, I have seen these kind of kids multiple times. It's not the first time I'm teaching here, right? Multiple times I have seen these kind of kids, right? In my class, if you spam, you will see a different avatar of Diksha Ma'am, right? I'm the sweetest person. If you're nice to me, if you do all these bullshit in the class, then you have no idea what I'll talk to you, right? So don't do all these stupidities in the class, right? So just relax, right? Try to focus, try to understand, right? Because all these things are not going to spamming, getting attention of the teacher, right? Because ma'am is teaching me, I need to get attention of the ma'am, right? All these things are not going to get admission to JEE Mains or JEE Advanced, right? If you want to be like them, right? Like Daksh, if you want to be, you need to be very sincere. And trust me, these students are not like well, just spamming this and that. They're fully concentrated that what exactly ma'am is teaching, right? So you need to understand what I'm teaching, right? Okay, chal. Ma'am, what about diamond? See, diamond is actually not I would consider it as an organic compound exactly. But yes, definitely it is made up of carbon, right? We will study that. It is made up of carbon. Graphite is made up of carbon. All these are the results of catenation properties, right? If you have seen your pencil, there is that pencil lid. The lid of the pencil, right, that you will see right inside the pencil, that is black in color, that is graphite. That is because of the arrangement of so many carbons, right? They have this graphite. That also you have studied in class 9th or 10th, you must have studied. Diamond is also 3D network structure, right? That diamond is also made up of carbon only. That's why we say that carbon is what? Koala, right? Carbon is coal, right? Even the in the when if you have seen people doing like pressing clothes, right, in the streets, what they use? They use black color carbon, right? So that is also carbon. That is like nobody purchases the carbon, right? Koala, nobody purchases that, right? So that is so cheap, but diamond is so expensive. Why so? Why so? Tell me. You're also the same person. And tell me one thing. You are right now what? You are right now a diamond in making, right? Right now you are just a carbon, right? Just a carbon. You have to now, how does carbon get converted to diamond? Under lot of heat, pressure, maybe some are natural diamonds. Now we have lab grown diamond as well. You can see, you can purchase that is at a lower price because they are lab grown. But the diamond, natural diamond is under like earthly condition. In natural conditions, it is formed under very high temperature. So when you also, when you are a carbon right now, when you do a lot of hard work, right? Day and night, you are studying, you are practicing, right? Like giving mock tests, everything you are doing, you will be converted to a gem, a diamond, right? So that's why I say you might be a carbon now, but you will be a diamond one day if you keep working on one day, because once a diamond was also a carbon. So once these shining stars that you can see here, they were also like you only. One day they were also like you, very initial stage, learning new things, but now they are your inspiration, right? So always, always keep this in mind, right? Chemistry is not only about studying chemistry. Chemistry also tells you some, gives you some life lessons. It also teaches you like so many things, right? Okay. So we have two kind of things. One is that because of this catenation property, what you will see, very large compound and large number of compounds. Now let us see one more thing here. That is wait a minute. Let us see one more thing here. How many kind of structures like chains you will see, right? In organic chemistry, you will see different type of things, right? Once you will see that, okay, this is one carbon, okay? This is carbon, this is carbon, this is carbon, this is carbon, this is carbon. This is connected to hydrogen, hydrogen, hydrogen. Whenever you have any spaces left here, hydrogen, 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 hydrogen. This, can you see it is a straight chain, right? Ma'am, how it is a straight chain, ma'am? Students ask, ma'am, right? When you like just enter class 11, these kind of questions are very normal, right? You say, ma'am, how it is a straight chain? It is moving like this. How come you're saying it's a straight chain? Whenever we are talking about straight chain, branch chain, closed chain, ring-like structure, we are only focusing on the carbons. We are not focusing on the hydrogen atoms, right? So let's just focus on carbon. Can you see carbon is giving you a straight chain here, a straight chain. So that is called a straight chain structure. That is called a straight chain structure. Now let's see, you have carbon, carbon, carbon. This is also carbon, this is also carbon. Now hydrogens I am not drawing here, I'll just write hydrogens. Instead of writing this 1, 2, 3, you can also write things like this. This is carbon is connected to one carbon. How many valencies? It is left with 3 valencies. So you can just write CH3. Here also it is left with 3 valencies. So you can write CH3. 3 valencies CH3, 3 valencies CH3. Here the carbon tetravalency is completed. Right? Now can you tell me, is this a straight chain? It is not a straight chain. Right? It is like this. It is no, it is a branched chain. Can you see? It is branched. Like trees, you have branches. No, this is the tree, right? You used to make these kind of branches, branches of the trees, right? There is one branch that is further giving you branches, one tree that is further giving you branches. You'll say, ma'am, what kind of tree you have made here, right? Red color tree, and that horrible tree is looking like something, some amoeba or something, right? So branches we are talking about, right? So that is your branched structure, okay? That is called branched structure, right? So as you can see here as well, right? This is a straight structure. This is a branched structure where this is a straight line, but you have branches in between, right? Like in the trees, you have branches, right? Then there is cyclic structure, right? That is represented by cyclic or cyclo or cyclic. This is represented by that. Let me just show you that also, right? I think I need to have an extra page of this, right? I'll just copy an extra page here, right? Now, students, we are going to see the cyclic structures. Can you tell me what are the cyclic structures, guys? Cyclic structures are which are closed structures, right? So what you will see, cyclic structures are, this is one carbon, this is one carbon. Let's say I'm drawing 5 carbon cyclic structure. So it will be like this. And if you want to draw the hydrogens, carbon already 2 valencies are occupied. 2 valencies we are left with, so draw CH2. 2 valencies are occupied, 2 are left, CH2. 2 are left, CH2. 2 are left, CH2. 2 are left, CH2. Right? That is your cyclic structure. It can be, tell me one thing. If you have one carbon, can you make a cyclic structure of it? If you have a 2 carbon, can you make a cyclic structure of it? If you have 3 carbon, can you make a cyclic structure of it? Everybody in the chat box, if you have, it's like a closed, very good black hole, very good, right? Okay, yes, very good, Jitosh. Isomerism, this I am also going to give you a little hint about isomerism in today's lecture. No, ma'am, which is not going to show you, very good. One carbon with one carbon, tell me one thing, it's like you people are like making a circle. You're joining each other's hands and you're making a circle. One person can make a circle? No, right? One person cannot make a circle. 2 person can make a circle? No, right? 2 person can just hold each other's hand. They can't make a full group circle, right? So you have 2 carbons. See, they can just connect to each other. If you have 2 carbon, there can be some circular loop that can be formed, right? 2 carbon is also not possible. 3 carbon, is it possible? 3 carbon, is it possible? Yes. 3 carbon, it is possible. 3 carbon, it is definitely possible to make a structure 3, 4. So beyond 3, you have the cyclic structures. Okay. So these kind of structures that you will see, one is single, straight chain, then there will be branched structures, and third will be your cyclic structures that you will see in your organic chemistry. Okay. Right. Now, let's talk about this also we have done. Now let's talk about this. So why carbon is a king? It has two properties, catenation, tetravalency. So have you ever played this? How many of you have actually played this game? Right? I love it. I even played today. I have a niece, right? She has all these toys and I love playing all these games. Why? Because with one block, you put one more block, you put one more block, one more block. You can make anything that you want to make, right? Like this, you can make a house, a car, anything that you want, right? So same thing is with carbon. Same is carbon. You give it 10 carbons, 20 hydrogens, different structures it can form, right? So with the same amount, different kind of structures can be formed. Same that we play this Lego brick game, right? Same thing is like carbon. You make carbon, you attach different compounds under different conditions. You will have different structures that are formed, right? Okay. What about Buckminster fullerene? I am not talking about, these are allotropes of carbon, okay? That we will more study in inorganic chemistry. That's why my focus is not teaching you carbon, its allotropes and all that. My focus is so that when you sit in the class of organic chemistry, you should not go blank that, oh my God, what this teacher is doing so fast, right? You should be clear in your head that, okay, this is structure, this way I can easily also make, right? So from these structures, I am going to take you to a next level of structure that we will see, right? Okay, understood? That's why I'm not getting into allotropes and all that. Let's skip that, right? Let's only focus on the basics, that is structure, how to draw structure. My main focus is today that you should not be scared of organic structures. That is my main focus, right? Okay. Now, let's see where do we find carbon, okay? After that, we will study the language of organic chemistry, right? Where do you find carbon? Now, this is going to be a very interesting segment of this session, right? Where do you see carbon? Carbon is everywhere. Yes, you are made up of carbon. Ma'am, but I am not black, ma'am. You're saying I am made up of carbon. Carbon is, ma'am, totally a black color compound, right? I am not saying you are made up of pure carbon like carbon, kohela, carbon. I am saying that you are made up of those compounds in your body that are made up of carbons, right? So let's say, where do you find carbon? Carbon is there in proteins. Carbon is there in fats. Carbon is there in DNA. Carbon is there in carbohydrates. And ma'am, are we going to see this? Ma'am, are you going to teach this in class 11th or 12th? Yes, I am going to teach this. Can you name the chapter? The chapter will be biomolecules. It is a different chapter, biomolecules. See, I teach NEET aspirants also, JEE aspirants also. NEET aspirants love this chapter, JEE aspirants hate this chapter. Right? I'll tell you why. Because it is more concerned about our body, right? That what is going in our body, right? Like proteins, fats, carbohydrates, sugar, glucose, sucrose. We'll talk about all of that, how actually these are made and all that, right? And this is a different chapter as compared to other chapters that you have in your class 12, right? Others are like simple functional group and this. So this chapter is entirely different from them, right? Then I think that this chapter can be refreshing to your mind, right? Because you will actually study what is in your body, right? So things that are around you, right? Things that you're eating, right? Your body, everything, almost everything is made up of carbon and its compounds, right? So you can see these were the food, right, that we're eating, right? Spinach, you have prawn, cucumber, all these food what you are eating, right? They have some element of carbon in it, some compound of carbon in it, right? Plastic, ma'am, this we are not eating. Plastic, I told you, plastic, polythenes, all these are your polymers of organic compounds of carbon, right? So all these are fuels. If you say fuels are also made up of carbon, so like we are surrounded by organic compounds. That's why we have to give it a different name in itself, right? Okay, that was the reason that you are why you're going to study organic chemistry, why it is so important for you, right? Because it is found everywhere around us, right? We are made up of carbon, right? Okay, tell me one thing, carbon is combustible or not, right? Carbon is combustible, right? When you burn carbon, right, what happens, right? Heat is produced, right? It is burnt, it is burnt completely. Now if you see one more thing, uh, what has happened, if you all must have heard about the news about airplane crash, right? So because we are made up of carbon, right, we can't survive heat, we can't survive explosions, right? That's where those people in that plane, they're not alive. Why? Because we all are made up of carbon, right? We are combustible. We, if we are like someone with the fuel also, right, gives us heat, then we will burn, right? So, and I'm the very like no, like I have nothing to say on that, right? What has happened, I know it is actually very scary to sit in a plane now, right? When someone is going from your family, saying them that okay, have a safe journey, because you never know. It's, see, can you see, life is so unpredictable, right? From that thing we can say that life is so unpredictable. 45 seconds, like they have just clicked the selfies, like send it to your their parents, relatives, everybody, and after 1 or 2 minutes they were not there, right? So can you see that life is so unpredictable, you have no idea. All we, like, we think about this and that, we are sad about what we have, we don't see what we have, we don't enjoy what we have, right? Life is so unpredictable, you never know what is going to happen tomorrow, right? You never know, uh, the person you are talking to right now, is this the last time you're talking to them, right? So my advice to all the students out there, uh, please be kind to people around you. Be kind, because you never know what is going on in their life. You never know, are you seeing them from the last time or not? You never know about life. Like, life is unpredictable, right? What life has for you in the future, we don't know, right? It may be best, it may be worst, but we have to accept it, right? So be kind. And one more thing I myself have learned from this plane crash is that, whenever the air hostess, if you've ever sit in a plane, whenever air hostess is telling you that these are the safety conditions, this and that. Now, there was one survivor in that, right? Yes, God was with him. Definitely, God was with him. But just imagine if he has never listened to the air hostess, he had no idea how to open the gate because everyone was dead or maybe not conscious around him, right? He had only nanoseconds to respond to that, to open the gate and get out of that. Right? How important is attentiveness for you? Even I have learned it myself, that how important is that. Usually when the air hostess is speaking, we all are either talking to our family that okay, I'm taking off, or if we are on our phones or we have just earphones on, right? We never think that actually we should not say this, but you never know if life puts you in a situation where you have to use this, right? So so many lessons, right, that we have learned from this, isn't it? Yes. Okay. Wait a minute. Your request is granted, beta. Okay. So I think that's all. I was not like thinking of talking about this topic, but I felt that okay, if you're talking about explain that definitely these things should also I should talk to, because you are right now teenagers, right? But there's so many things that I have learned from life, that yes, life is, you don't know what is going to happen. So you have to be like really, really be happy in the place you are, be happy, and be very uh, good to your parents, right? You never know. So parents have unconditional love. Just thinking about the families who have lost their child, who have lost like entire families are now gone, right? Think about that, and that just screws up with your mind. Definitely a horrible, horrible incident. Horrible, horrible. I just pray that Air India and the government of India uh, finds that what exactly has happened. And I know that the next time I'll be in a plane, my heart will shrink. I know that my heart will shrink, because thinking that I might be, we anyone from us could have been on that plane, right? So yes, right. Sure. Now let's understand the language of organic chemistry, right? There is a language of organic chemistry. For that, first thing is condensed formula, right? See, this is bond line formula and this is condensed formula, right? This formula I have taught you that when you draw lines, you show the bonds, and this is how directly you write it. In your entire organic chemistry 11th and 12th, you are not going to use this. This is very time consuming. You are directly going to use this, that's CH. You're only going to write CH3, CH2, CH2, CH3, how it is so. It means these three hydrogens are with this carbon. These two hydrogens are with this carbon. These two hydrogens are with this two carbon. These three hydrogens are with this carbon. That's how you write it, okay? That is called the condensed formula, right? That is called the condensed formula. For example, I ask you to write, this is 1, 2, 3, 4, 5, 6, 7, right? Now, this is what you need to write, and if you write it in a this way, that is your bond line formula, you will write it somewhat like this. HH, this will be 3 hydrogens here. This will be 2 hydrogens here. This will be 1, 2 hydrogens, and this will be 3 hydrogens here, right? Now you need to write it in the form of condensed formula. So this is CH3, right? You write this is CH, this will be your C, this will be CH, this will be CH2. What I write it, I usually mention it like this. This is CH, this is CH2, this is CH3, right? This is a mix of both. You can also ignore this line here. You can just write it CH, because this is only one hydrogen. This is CH2, right? And this is CH3. This carbon is CH2. You can mention it here. This is CH2. And then what you have is CH2, right? Then you have is CH3. So this is your condensed formula. This is the condensed formula in the condensed form, how you write it. And this is your full bond line formula. Okay. Now, there is also one more way of representing this, right? Now, I am going to convert this into a simple, sorry, bond line again and again I am saying. Now, I am going to convert this into a simple line formula, right? So, how? That means only lines will be mentioned here, right? So, this is one carbon. How many carbons I have? 1, 2, 3, 4. So, how will I draw it? 1, 2, 3, 4. You will say, ma'am, why this zigzag line you have drawn? See, if I would have written it like this, 1, 2, 3, 4. Would you have understood where is first carbon, where is second carbon, where is third carbon, where is fourth carbon? No, right? Okay. To understand that, you have to write it 1, 2, 3, 4. 1, 2, 3, 4. Right? Now, to this fourth one, to this second one, you have 1, right? You can also write it like this. 1, 2, and this is 3, right? because this is 1, 2 and 3. This is how it is represented. And this is why students get scared. Ma'am, what is this? Right? This is also how you mention that how you will actually understand what is this. Whenever you see a simple point here that is showing you carbon, right? All these are carbon, right? And hydrogen is not shown here, right? Hydrogen we don't show in such cases, right? In this formula, in this type of writing the formula, we don't show hydrogen. We simply write carbon, carbon. We assume that, okay, here hydrogen must be there, right? So if nothing is written, that means hydrogen it is. Okay? Understood everybody? Yes, you should mention only C. Yes, line is what will be useful for you in the class 11th and 12th. This is still useful, but you have to convert this to this, right? In most of the cases, you will use this thing only. Even once you have practice of this, you will avoid writing this, right? You will write only this way, right? Now, I will write some formulas for you here. Let's say I am writing 1, 2, 3, 4, right? 5. Can you tell me how many carbons it has? Just tell me how many carbons it has. How many carbons it has? How many carbons? Yes, everybody, which is the main branch here? Which is the main branch? Very good question. Main branch will always be the maximum number of carbon. Okay, that we will study in GOC, in the IUPAC naming, because we have to understand the name also. Right? You are going to understand organic chemistry. So first topic will be understanding names, right? So the one that has maximum number of carbon will be your parent chain, right? Okay. So this is your having this number of carbons. How many carbons? 1, 2, 3, 4, 5 and 6. So number of carbon is 6, right? Can you also tell me how many number of hydrogens are there in this? How many number of hydrogens? Who will tell me? How many number of hydrogens are there? Right? That, ma'am, will that be useful? Yes. When you will use GOC, you have to also answer how many number of hydrogens, because you have some effects where hydrogens plays a very important role, right? So also should know, by seeing the structure also you should know how many hydrogens, right? So I am going to draw the hydrogens here. This is carbon, 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 carbon. 1, 2, 3 hydrogen. 1 and 2. This is 1 and 2, right? Usually it is drawn like this, only in these kind of cases, na, it is drawn like this. Okay, this is 1 and this is the second hydrogen. 1, 2, 3, 1, 2, 3 and this is 1. You have to complete the tetravalency of carbon, that is the main thing, right? So here what you will see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Carbon is 6, hydrogen is 40. Right? Carbon is 6, hydrogen is 40. Okay, everybody? How long the session? Mostly we have done only, I think, 15 minutes more to the max. Right? Now, if I draw a structure like this with you, if I draw a structure like this, can you tell me how many carbons are there? Can you tell me how many carbons are there? How many carbons are there in this kind of structure, everybody? Can you tell me how many carbons are there? Yes. Carbons are 6. Okay. Carbons are 6. How many hydrogens are there? How many hydrogens are there? Very good. How many hydrogens? 1, 2, 3, 4. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So number will be 12, right? So you know how it is written. It is also written, this particular formula can also be written like this. Not formula of this compound will be written like C6H14, right? This compound will be written like C6H12, right? Okay, that is how it will be written. Okay, very good, right? So guys, I think this base, if you know now, most of the things will be easy for you, right? And this is the basic thing that we will study in chemical bonding, right? This we will study in chemical bonding. Because why we will study this in chemical bonding? Because that will be required for to understand. See, I am telling you about, first is I am telling you about carbon compounds, but also you will do some reactions in organic chemistry, right? For that, in organic chemistry, reagents are very important for you. Like some compounds of inorganic chemistry will play a very important role here. Like how is carbon dioxide? How does it look like? How does water look like? Right? How does nitrogen has 1, 2, 3, 4, 5 outermost? All these things are very important for you in understanding organic chemistry mechanisms. If you actually want to crack JEE mains in advance, then these things are very important. That hydrogen has 1 outermost, calcium has 2, aluminium has 3, carbon has 4, nitrogen has 5, oxygen has 1, 2, wait a minute, oxygen will be 8, no? So 1 is 2, 2 is 2, 2p 4, 4 it should be. Acha, it is forming that, no? 2, for outermost, so it is 6. Yes. So sorry, my mistake, right? Because oxygen is right now not forming any bond, so it will be outermost electrons are, you have outermost electrons as 6, but you know what will happen? This will be occupied, this will form a bond, this will also form a bond, and in oxygen always you will have 2 lone pairs. On nitrogen always you will have 1 lone pair. Why especially I am telling you about oxygen and nitrogen? Because you will see compounds, see when you will see functional group, in the functional groups of organic compounds, oxygen containing compounds you have like you have phenol, you have alcohol, you have CO containing, that is aldehyde ketone, all these compounds. For that you should know that oxygen always have 2 lone pairs and nitrogen always have 1 lone pair. Other are in the bond formation, right? Okay, that you should know definitely. That is very important for you. Chlorine always have 3 lone pairs. That means all the halogens have 3 lone pairs and always it is it is forming 1 bond, right? Ma'am, where we will learn all this you will learn in inorganic chemistry periodic classification, right? This all you will learn, especially in P block you will get to detail of this, that why it is so, right? Argon, it is a noble gas, right? It is forming 1, 2, 3, 4, 5, 6, 7, 8 outermost electrons it is having, right? Then carbon dioxide is having this kind of structure, which is a linear structure, right? H2 is having this kind of structure. Can you see one thing? Oxygen, one oxygen is forming this 2 lines here. This is 1 line. For that, you need to understand what is this 2 line, 3 line, what exactly do you mean by that, right? For that, where should I teach you this? I should teach you here. So, bacha, you have basically three kinds of bonds you will have. 3 kinds of covalent bonds you will have. One is single bond, then you have double bond, then you have double bond, then you have triple bond, right? Ma'am, how it is formed? Again, beta, all of this we are going to study in chemical bonding. Single bond is represented when 2 atoms are sharing 4 electrons. That means when 2 atoms are sharing 2 electrons. One single bond, this is double bond, and this is triple bond, right? Here, 2 atoms are sharing 2 electrons. Here, 2 atoms are sharing 4 electrons. Here, 2 atoms are sharing 1, 2, 3, 4, 5, 6 electrons. Each single bond is having 2 electrons in it, right? And that's how in full organic chemistry you will see single bond, double bond, triple bond a lot. And that plays a very important role in the mechanisms of organic chemistry. Okay? Now, that's why what you will see, This carbon, see, simple thing is, this is the carbon, okay? Carbon was like, I want to have 4 bonds. I want to make 4 bonds, right? You had only 2 oxygens. Then what it did, right? I'll explain you full in chemical bonding. Here I'm just letting you know a simple concept here, that carbon will form 1 double bond here, 1 double bond here, right? So I told you, whenever carbon, this and this bond is occupied in the bond formation, you will be left with 2 lone pairs on each of them. That's how this is the structure, right? And here, this is oxygen. It is again having 6 electrons. This electron is forming bond with hydrogen. This electron is forming bond with hydrogen. Oxygen is having 2 lone pairs here, right? Anyone of you have this question in their mind that, ma'am, why this is a linear structure? So don't worry. It's not like I'm going to teach you in a way that you'll be like, ma'am, what is this, ma'am? I can't imagine. It's not like that. I'll teach you with proper structures in my hands, right? Okay. Don't worry. I'll teach you like this. So all these structures, I'll teach you in chemical bonding. Why it is linear? Why this is not linear? Why it is like this? Why it is not a linear? Why it is not like this, a straight line? Right? All these things we will study. Right? In chemical bonding. Full detailed structure. But for your this structure here, all you need to do is for your organic chemistry, right? Some basics of chemical bonding will be used. So now let us see. Draw the electron dot structure of CH4. This I have already drawn. If you remember, we have already drawn. This is C1. This is having 4 unpaired electrons. 4 outermost electron. And this is forming hydrogen. Hydrogen is giving 1 electron. Hydrogen is giving 1 electron. Hydrogen is giving 1 electron. That's how it is making 4 bonds here. Right? That is called the dot structure. Okay. Similarly, nitrogen. This is nitrogen. Nitrogen is having how many outermost electron? 5. 1, 2, 3, 4, 5. Now, nitrogen always leaves 1 outermost. Always it has 1 lone pair, right? So, this will not take part in bonding. It will require 1 hydrogen electron, 1 hydrogen electron, and that's how it is forming NH3 structure here, right? Okay, ma'am, where we will study this? Again in chemical bonding. You'll see, ma'am, so much of organic chemistry to understand chemical bonding is required. Yes, you require chemical bonding for that, right? Now, students, you can see this here. This is structure formula, bond line formula that I told you, right? Structure formula is 1, 2, 3, 4, 5, 6. 6 carbon in straight chain. Straight chain is represented by zigzag format. So it will be 1, 2, 3, 4, 5, 6. Right? Now, next is 1, 2, 3, 4, 5. That means this is the straight chain that you have 1, 2, 3, 4, 5. And one CH3 group is attached on the second last carbon. So that's why this one line here, whenever you see this one line, see, for example, you have this structure and you see one line here. That means one CH3 group is attached. This means one carbon CH3 group. You have 2 lines, that means 2 CH3 groups. You have 2 lines here, that means 2 CH3 groups are attached. Okay. This line, one line is representing you one CH3 group here. Right. Now, ma'am, bromine, ma'am, it also has some different representation. No. Carbon is mentioned by the line. Hydrogen is not written only in the bond line formula. Other compounds like oxygen, you have bromine, chlorine, nitrogen, you have to write the symbol there, right? So this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Bromine is written on the 3rd position, Br. Okay. Then here you have 1, 2, 3, 4, 1, 2, 3, 4. Second position, you have CH3 here. Now the question is, ma'am, why we have not drawn it like this? 1, 2, 3, 4, 1 CH3 here, 1 CH3 here. Is there this kind of question, right? Okay. See, this is a very weird structure, right? always when you have on the tip of that, see, it's like this, on the tip of the carbon, you always substitute. Substituent is whenever you replace hydrogen. See, simple thing is what would have been there. This is 1, 2, 3, 4. It should be 2 hydrogens here. You replaced 1 hydrogen and you replace it with 1 methyl group, right? So on the tip only you will replace the substituent. Okay, that's why it is written like this, to make a symmetrical structure, right? Otherwise, what will happen? It will not be a symmetrical structure if you're making it like this. Okay, there are also some symmetry. Organic also needs beautiful structure, no? So you can't just make any bond there. So this is 1, 2, 3, 4. You make 4, 1, 2, 3. Achha, tell me how many hydrogens are here. You have 1, 2, 3, 4, right? This double bond is present here. Now, can you tell me how many carbons? Carbons are 4. Now, tell me how many hydrogens are there in this structure. How many hydrogens are there in this structure? Anybody? 1, 2, 3 hydrogen. 1, 2 hydrogen. This is having how many hydrogens? Carbon is already forming a single bond. It is forming 1 double bond. That means 3 electrons are already occupied. It just need 1 more hydrogen. So 1 hydrogen here. This carbon is forming 1 double bond. 2 electrons are already occupied. So it just need 2 hydrogens here. That's why the number of hydrogens will be 1, 2, 3, 4, 5, 6, 7, 8. Hydrogens will be equals to 8 here. Right? Okay. Okay, everybody. Yes, everybody. If that is clear, then let me know in the chat box. Right? Okay. I think that's it. This we have already done. Line structures I have already told you. Right? Now, let's talk about isomers. Okay? This also in JEE means almost every paper, almost every attempt, they have asked one question on this, right? Even in JEE Advanced, it's not like, see, JEE means JEE Advanced, the only difference is that JEE means they ask you from one topic, right? Maybe they'll mix 2 topics, right? But in JEE Advanced, it will be like 1 topic, 2 topic, 3 topic mixed together. So isomerism is a part of the question. But most probably isomerism kind of question will be there, right? And this is a base of isomerism, right? What is isomerism? It is actually that the molecular formula is same. Let's say, what is the molecular formula here? 1, 2, 3, 4, 4 carbon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens, right? What about this one? 1, 2, 3, 4. 4 carbon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens, right? What about this one? What about this one? Right? Achha, these are the same things only. Achha, you can ignore this part because this is a high level part that I will cover. The name and all that I will cover in IUPAC naming. Okay. So now remember one thing, the molecular formula is same. When the molecular formula is same, the structure is entirely different. Here they have written it in like completely in the expanded form. This is written in bond line formula, right? Can you see the structure is entirely different? One is making this Y, other is the zigzag format, right? That means the structure is different. The arrangement of the atoms is different. The molecular formula is same. That is called the isomerism, right? So I give a very simple example, right? Have you ever seen cars, right? Cars, like you can think about cars, you can think about dolls, you can think about anything, right? Or you can think about, in fact, those cubes, bricks. I think that would be a good example because everyone can relate to it, right? So if you are provided with 7, 8 blocks, right? Someone will make a triangle out of it. Someone will make a rectangle out of it. Someone will make a truck out of it or car. Someone will make a house out of it, right? Different things you can make. If you give 10 students those bricks, every single student will make a different structure from those bricks, right? Why? Because the arrangement is different, the linkage is different, right? So that thing, they all, because they have used the same number of bricks, but they are forming different things. So that is nothing but that is isomerism only. When you're using the same compound, the same atoms, the same number of atoms you're using, but you are getting a different kind of structure, that is called isomerism, right? Okay. Now, students, this is very interesting. You are going to see, let me just show you this here also, right? Just give me a second, right? This is your CH4. Tell me what you were thinking about CH4. How does CH4 look like? Wait a minute. How does CH4 look like? Next session, wait a minute, beta. Next session, when, ma'am? Next session is going to be on, I think, Wednesday or Monday. I'll let you know on the Telegram channel, right? Next session, I'm going to start with real chapters, right? But before that, I wanted to do this basic so that, you can get an idea what exactly is going to happen, right? So, can you see this structure? This is the structure that is drawn here, right? 3D structure, right? Don't get into, ma'am, what is this angle? What is this bond length? No, right? Just remember that in reality, these organic compounds are not like this. 1, 2, 3, 4, ma'am, it is like this. No, this is not how they are in reality. In reality, because of so many things, they are like this. Okay, they are like this, right? 1, 2, 3, 4, like this. Okay, so it's not like every other molecule is like this. I have just given you example of CH4, right? Because carbon is forming 4 bonds. Usually it is in this kind of structure, right? This one example I have given you, right? You can see C2H4, right? You know how C2H4 will exist. Can I give you that? Just for fun, we are doing this, right? 2 bonds I'll leave here, right? Now I give you that how exactly this double bond looks like. So you can also get an idea, na? You just can't cram things. You are human beings, right? See, this is one hydrogen, other hydrogen. This is the double bond. And you know how it is formed? How it is formed? Let me show you. This is the double bond. Let me just attach hydrogens also into it. Right? Yes. That I'll teach you. Don't worry. We'll study all of that. Array, this was only three bond it was able to form. 4 bonds we need. 1, 2, 3. Again 3. 1, 2, 3, 4. ठीक है. See, just now don't think about the reason and all that. That I'll teach you. That I'll teach you. Right now, just think that whenever I talk about this CH4, right, that is an alkane that you will study in hydrocarbons. That is alkane, right? This is alkene. This is C double bond C. This is H2H2, right? This is alkene. This is alkyne. This is alkyne with a triple bond that you will study triple bond. This is CHH, right? But how they actually look like, okay? So CH4 I have shown you. This is how this is how alkyne, that is ethyne, will look like. You will have a double bond, 1 hydrogen, 1 hydrogen, 1 hydrogen, 1 hydrogen. That is how it looks like. Okay. If I add, now this is your ethyne. Can you see that? If I replace this one more bond here with a double bond, right? Then I will be able to show you how does a triple bond look like. Okay. Can you see this? This is a triple bond. These 2 carbons are 1, 2, 3 bonds they are making. 1 hydrogen and 1 hydrogen is here. Can you see that? That's a linear structure. Okay. So that's how, depending upon different like functional groups, you will have different structures here, right? So that I have just shown you the structure of this alkane, alkene, and alkyne. But in reality, we will discuss a lot of things, right? That is going to be your, firstly, we are going to discuss hydrocarbons, in which we will discuss alkane, alkene, alkyne, properties, all of these we will discuss. Arenes, aromatic compounds, benzene we will discuss. This all we will discuss in class 11th itself. After that, in class 12th, first chapter will be haloalkane, then haloarene will be there, then aldehyde, ketone, carboxylic acid, alcohol, ether, then you have ester, acidic anhydride, amide, acyl chloride. All of these things you will study in your class 12th. This is your class 11th. This is class 11th, right? Now in class 11, ma'am, you will think, ma'am, that means class 11th organic chemistry is not that important, right? Ma'am, just one chapter here, right? Isn't it? Now, I think I need to have more blank slides after this, right? Okay. Now, let me just give you a like overview of how we are going to study what, right? So guys, firstly, we will study in your class 11th, right? I'm not just giving you the syllabus, I'm giving you the proper way, that which should be the right way. Class 11th, this is class 12th. Even if you are a dropper, you're in class 12th, you have to follow this sequence only to understand organic chemistry. First is you will study GOC. GOC, we will not talk about any compound as such here, right? But to understand GOC, the lecture that I have taken today about the structure, this and that is important for you, right? Now, in GOC, you will study about some effects, right? That you will use in throughout organic chemistry. In JEE Mains, JEE Advanced question, they don't just ask you the reaction, they ask you reaction mixed with GOC, right? So GOC is the most scoring thing that you have. GOC is most important. And here you will study effects, you will study IUPAC naming. Why IUPAC naming is important? Because sometimes in the options, they don't give you the structures, they just give you the IUPAC naming. They give you the common names, right? Common names also you have to study here, right? Then you also have to study isomerism, which is again a very important topic. That can be the, you know what is the beautiful thing about GOC? It can be asked to you as it is. It can be asked to you related to any other chapter throughout your syllabus. That's why GOC becomes very, very important, especially for JEE Mains and JEE Advanced students, right? Now, once you do this, we'll talk about hydrocarbons, okay? Then we'll study hydrocarbons. Now, hydrocarbon is, you will study about the alkene, alkene, alkyne, aromatic compounds. Then you will study, mainly you will study these things: physical properties, chemical properties, preparation steps, right? That's it. These three things you will study for every other functional group. Why this is important? Because in your class 12, reactions are repeated, right? Reactions are repeated. Once you see this chapter in detail, because it's a very lengthy chapter, right? Once you know this chapter in detail, other class 12 chapter becomes easy for you. Now, in class 12, you have halogen containing, you have oxygen containing, right? You have nitrogen containing. These three things. Halogen is haloalkanes, haloarenes, right? Oxygen is aldehyde, ketone, carboxylic acid, alcohol, phenol, ether. Then nitrogen is amines, amide. All of this you will study here. But you know what is, this still is easy. Most difficult part is this one, because you have just jumped out of class 10th. This you will find difficult. But when you start ignoring this part you are already going to mess up in your class 12. That's why this part is very, very important for you. And I'll start firstly with physical chemistry, right? I'll start because physical chemistry is the base, right? If I directly start with organic chemistry, you will get scared, right? It's not a scary thing as such, but the flow of chemistry should be there, right? So because you have studied mole concept already, right? So first chapter that will pick is some basic concepts of chemistry. Then we'll study structure of atom, right? Then we will study, after structure of atom, equilibrium and thermodynamics I am not going to teach you, right? Because those chapters are slight, individualistic chapter. After structure of atom, I'll teach you periodic classification and then chemical bonding. Then we will start with organic chemistry. Because for organic chemistry, there are some chapters that are required before. Simultaneously, I'll complete uh, equilibrium and thermodynamics also, right? So don't worry about that, right? Okay, so that is going to be the flow of class 11th for you guys, right? And those who also wants to prepare themselves for class 12th, firstly, that is not an advice, that is also only an advice to those students who are in class 12th right now, because class 12 students can watch class 11th and class 12th both, but class 11 students, they should firstly focus on the first 5 chapters that I'm going to teach you. Mole concept, then you have structure of atom, then periodic properties, then chemical bonding. Once these 4 chapters you understand completely, then any area of physical, organic, inorganic is open for you, right? Then you can definitely choose chapters of your choice, right? Okay, yes. Good, but organic haunts me every time I skip class 11th and 12th. I am dooming in it. Suggest me how I can start my organic from zero. Organic from zero, if you want to cover your backlogs, I can advise you one thing. You can go, if you have any idea, see, this is only applicable if you still have some idea about organic, right? Then you can go and watch my previous one shots of GOC. But one shots, definitely I will only recommend if you have some idea of like GOC. If you're completely blank, then you will have to wait, right? Before I'll take time to start GOC here, but you can watch my lectures, previous lectures that I've already taken on GOC, right? But that is a very quick GOC that I have done. So even if you have listened thoda sa in the class, then you will be able to understand that, right? Okay, and you can see for yourself, right? Why that kid is so tense right now, because we know that once your 11th organic is not good, 12th organic is already doomed, right? So you really have to work a lot to make the ends meet, right? Because they are interconnected to each other, right? So all the students who are in class 11th right now, please, you should learn from the mistakes of your seniors, right? We know that the students who have backlogs, how difficult it is going to be for them to complete the backlogs, right? So don't create any backlog, that would be the best for you, right? Okay, right? Okay. uh, Explain this question, ma'am. Number of future item, you can do one thing, just post it in the comment section. What I can do is I can post the answer on the on the Telegram channel, or you can message me on the Instagram, right? That would be better, right? Okay, so that's it for today, students. Now all the students, right, as I told you that our IB SAT scholarship program is open here, right, where you can give the test and avail 90% scholarship. For all the droppers, we are also giving them guaranteed rank improvement. You can visit, for all the students who are in class 11th right now, class 12th right now, guys, you can visit our nearby center. If you're living in Bangalore, then you can visit JP Nagar. If you're not living in Bangalore, then you can visit any center nearby you. You can see Tamil Nadu, Andhra Pradesh, Telangana, Punjab, Maharashtra, Delhi, Bihar, Odisha, Rajasthan, Pondicherry, Karnataka, Uttar Pradesh, all these centers here, right? What it will help you to understand how to prepare well for your exam that is going to be in upcoming 2 years, right? This is for all the class 11 students, and for all the class 12 students, and for all the droppers students. Already we have Sigma batch that is going on. This is for JEE 2026 aspirants, right? In the Sigma batch, students, we are taking live classes, mock tests are being taken, and it is completely in English. We also provide the modules. That modules we take every 15 days is a mock test analysis, like question practice round. Everything is there in the batch. You can check out the link in the description box. And students, one more thing, that I want all the students who are watching this video, right? If you find this interesting, right? If you actually like the way I teach, then I would like you to introduce yourself to me, right? Introduce yourself. If you are a new student, right? You're in class 10th, 11th, from which state you are in, and what is your aspiration, what you want to be. I want to know that in the comment section, right? Okay, because in the chat, sometimes I miss your chats, but I want to see whatever you're writing in the comment section, right? Okay, definitely, I have gone through 11 chapters and prepared the notes too, but I didn't have revised due to boredom from it. Very good, Invisible. You have to revise as much as possible. Don't ignore your class 11 when you're in class 12, right? Okay, yes. I don't have Instagram. Okay, future item, you can post it in the comment section. Okay, I'll definitely reply to you. That's my promise. Okay, now introduce yourself in the comment section. And guys, if you want to complete your class 11, then every 6 p.m. at 6 p.m. we take either physics or chemistry or mathematics. You will see any of one lecture here from Monday to Saturday at 6 p.m. And at 8 p.m. we take lectures for class 12, right? Physics, chemistry, or mathematics, right? So that's it for today, students. Bye bye. Take care. See you all in the next class. Bye bye.